Alright, welcome to episode 2. So, in episode 2 we're going to discuss the compound interest formula. Now the compound interest formula is related to the simple interest formula, but they are not the same. And so simple interest, if you remember from episode 1, simple interest can be found by just taking the principal amount, multiplying it by the rate times the time or the years of the loan or investment, whichever you're using this for, and that will be used to calculate your interest. It's simple to calculate. It's not compounded. Compound interest is a little more complicated. The idea behind compound interest is if you're investing money, then you'll be earning interest on top of interest previously earned. So interest is compounded. If you're taking out a loan with compounded interest, then you'll be paying interest on top of more interest. So what I mean by that is there will be a different number of times in which interest is compounded based off the situation. So if you look at this problem here, let's say we're investing $14,000 for 7 years with an APR of 4% and quarterly compounding. So that quarterly means, okay, well, usually when you think quarter, you think a fourth of something, right? So quarterly compounding would be a fourth of a year, which means every single year interest is compounded 4 times, or every 3 months. If you see the word annually compounded, then that will be 1 time a year. Semi-annual compound would be 2 times a year. Monthly compounding would be 12 times a year, and so on. And so if you look at the formula here, we know the A means the accumulated or final amount. P means principal. This is a 1, so that's never going to change. Plus your APR is your rate. Remember, you have to express the percentage as a decimal, the rate as a decimal. The N here is the number of compounds. So in our situation, in this example, we're going to put a 4 for our N because we are compounding quarterly. And then of course your Y is the number of years. Now sometimes you'll see a T here. In episode 1 I did use a T for time. In this formula we can use a Y for years. Sometimes you'll also see, instead of APR, you'll just see a lowercase r for rate. Just know that APR and R, this is a rate, and sometimes you'll just say a rate of some percentage. So let's plug everything in that we know. We're looking for the A. We're looking for the accumulated value, the final value. So we're going to say we took 14,000. 1 plus the rate, again, was 4%. As a decimal, that's 0.04. That's very, very important. Do not put a 4 there. If you did accidentally put a 4 there, look at your final answer, and it's going to be an extremely large amount. So if you make a mistake here, usually it's very easy to determine that there's a mistake being made if you look at your final answer and try to interpret it. So if you accidentally put a 4 there, you're going to get an answer in probably the billions, which wouldn't make any sense for this case because you're only investing $14,000 for 7 years. So if you make a mistake, sometimes it's easy to determine you made a mistake if you just try to interpret your answer based off the situation. So quarterly compounds, we're going to put 4 there, and then we're going to raise that to the power of 4 times the number of years, which was 7. So 4 times 7. Alright, and then to proceed here, I want to just briefly review PEMDAS, which is your order of operations. Your P is your parentheses, E is exponents, multiply and division is your M and D. Those are treated as a group, and you perform those left to right. And A and S is addition and subtraction, also treated as a group where you perform left to right. So what we need to do here is we have to be very careful in this calculation here. We want to take what's inside the parentheses first and go ahead and calculate what that is. Now, some people are experienced enough to where they can plug this all in one step in the calculator. I do not suggest that you do that, because a simple misplacement of a parentheses or mistyping a button or a number could really affect your answer. And so I highly suggest that you guys break this down into steps. So go ahead and find out what that parentheses is, what's inside that parentheses. Now, your calculator will perform the order of operations correctly. So as long as you type everything in correctly and very carefully, just the inside here, if I type that in, I'll get 1.01. But again, the calculator will perform the order of operations correctly, so that's why I do not suggest you trying to type this in all in one step, because if again you miss a parentheses or something, your calculator can't determine that you misplaced or even put something extra into your calculation. It's still going to perform the order of operations correctly, and so if there's a user error, your calculator is not going to solve that. So that's why I say break it down into steps to eliminate the chance, or help eliminate the chance, of making small errors. Also, the 4 times 7, we know 4 times 7 is 28, so you can write 4 times 7 again here, or you can just go ahead and say 4 times 7 is 28. And so now, if you follow your order of operations, you might think, well, why did I multiply? Well, the multiplication here is all in the exponent of this equation. So I'm allowed to take that 4 times 7 and just go ahead and say that that's 28. 28 is the exponent of this 1.01, the same as 4 times 7 is the exponent of that 1.01. So I'm allowed to do that, and that'll make it a little better for me. So if I take that 1.01 and I raise it to the 28th power, I'm going to get this. Now this is where we have to be very careful. Do not round until the end, until the very end. Okay, do not round until the very end. So if you're in the habit of taking what the calculator gives you and rounding this, if you accidentally round that to 1.32 and multiply that by 14,000, it's going to be incorrect. You know, we're talking about money here, so if my money's off even just the slightest amount, it's concerning, right? So if you're talking about money, you want to be as exact as possible. So this decimal right here, you do not want to round it. Instead, just go ahead and multiply. Just hit the multiplication button. Multiply. Go ahead and multiply that by that 14,000. And then there's your A value. That's your final amount. We can round that to the nearest cent, which would be 0.07. So our accumulated amount is $18,498.07. Right there. And so from there you can say, oh, I made almost $4,500 in earned interest. Okay, but you do need to be very careful. Do not round until the end. So that is the answer to this problem. We'll type it in just a second. But just to show you how rounding would affect your answer, if I take 1.01 and I raise that to the 28th power and I rounded that, let's just say, here's a mistake that I've seen. You know, you'll see that it says round to the nearest cent. That's not a cent right there, but I've noticed that some students do round that 2 decimal places. This is the exact answer. Let's see what would happen if I took that and I rounded it to 1.32 and multiplied that by 14,000. Let's see how much that throws off our final answer. This is telling me this is $18,480, and that's a difference of about $18.07. That's money that we're talking about. So just the slightest miscalculations of rounding in the middle of problems can throw off answers very a significant amount. All right, and so think about, you know, your money, right? Don't cheat me out of $18. All right, that's my $18. And so make sure you're not cheating yourself out of calculating this. Do not round anywhere until the very end. Alright, some students, and I do suggest this too, if you type this in again, round and not round it, oops, if you type this in again like this, in the next video, what I'm going to do is, just to help show my steps, I'm not going to round this. Well, technically I will round it, but I'm going to write down everything the calculator gives me. Alright, this, even if I just write down what the calculator shows me, that's still a rounded value, because there's actually some more numbers going on here. But for the sake of the next video, what we're going to do is, just to show our work, I would actually write that all the way out, 1.321290967, and then multiply that and get this answer. So there are some cases where I am going to write down everything in the calculator, but I'm not going to round it 2, 3, or even 4 decimal places. I'm going to write down everything that the calculator shows me, and that's going to help us in the next video. Alright, so the next video is a to be continued. We will still discuss compound interest. Well, let's check this answer first. I guess we haven't done that. Check answer. Good job. Alright, so to be continued. In the next video, we'll do a problem where we actually have to figure out how much we would like to deposit today if we want to have $30,000 in 6 years. So that will be the accumulated amount. So there's your little preview. I'll see you then.